Hello, everyone. Thank you for joining me today. I'm going to be talking about 10 years of Dynamo and Revit classes from one speaker. That's me. This is volume 3. I'm Marcello Sgambelluri. I'm the Director of Advanced Technology at John Martin & Associates. I've been speaking at Autodesk University for 10 years, and so this is a best of class. This is volume 3. I'll get into later about the volume 1 and volume 2. Twitter handle's there if you want to check it out. So let's get going. All right, I also published a book recently called Dynamo and Grasshopper for Revit, Cheat Sheet Reference Manual. You can hit the QR code if you want. Check it out. Very excited about this. Okay, so a little bit about me. These are some of the families that I have built inside of Revit over the last 10 years, basically. The reason I'm showing this slide, and we'll get into it a lot more detail later, is I just wanted to show that anytime I'm using Autodesk software or other software, I'm really pushing it to its limits, finding out what's practical, what's fun, and helping teach the world. And that's what I've been doing the last 10 years. So just think about it that way as we move forward. Okay, so what happened was in 2019, I decided to teach a class, since I've taught so many classes. I've actually taught 25, on summarizing all of those classes in one class. So that was 2019. And so the listeners have spoken. And then in 2020, which was last year, I did a volume 2, which then I was able to take other examples that I didn't show and show them in volume 2. And again, Autodesk University, as well as the listeners, were able to recommend me to come back. And now I'm doing a volume 3. So think of this as like a best of. And I'll explain how the format will work. But honestly, thank you so much for inviting me back. I really appreciate it. If you want me to do a volume 4, I would recommend you hit that recommend button when you leave so I could be invited back for a volume 4. I could probably do up to 7 volumes if I'm allowed to. Okay. Also, because of all that love and support from all you listeners over the years, I've actually won 17 first place speaker awards. And we'll probably get into a little bit that a little later, like which classes actually got top rated. Okay, so this next hour is going to be hardcore. I showed you some of those examples. And so we'll be covering it. Because we only have 30 minutes, I won't be going into too many live demos, but I've got to cover 25 unique examples. Here is all the 25 classes that I've taught over the last 10 years, since 2012. If we count this year, that would be 10 years. What I'm going to do is I'm going to go over each one of these classes. I pick one example. That's 25. We're going over today. That's what I did in volume 1, volume 2. Now we're in volume 3. Okay, here we go. So what we're going to do is let me mention a few numbers here that I'm really proud of. Okay, 25 unique classes over the last 10 years. Again, thank you. That's over 200 examples that I've created. Okay, so volume 1, I picked 25. Volume 2, 25. Today we'll be doing probably 26. That's over 1,000 pages of handouts and over 15 gigabytes of data sets. So what I did is I gathered them all up and I put them on an FTP site. You can use this QR code and get them, look through them till your heart's content. The number I'm most proud of is I was able to teach thousands, even tens of thousands of people, Dynamo and Revit through the 10 years again. So thank you very much. Okay, so on the right here, this is what a 1,000-page handout looks like. You can get that through the QR code. Today, we are going through about 26 examples. That's the smaller handout that you see here. This is available on the Autodesk University online site with this class. So you're able to get that in a summary of all the classes. Okay. Large handout, QR code, small handout, AU online. Okay. So this is how it's going to work. I'm going to go over an example for each class. And they're going to be in these one-page summaries, and that's the best way I could go over 25 examples in this short amount of time. Okay, let's start from the beginning. 2012, I taught a class on graphical column schedules. Why would you teach a class on graphical column schedules? Graphical column schedules are basically system families that are locked down pretty hard. There's not much you can customize, but they do allow tags, column tags. So what you can do is you can modify the column tags and put in data in there, shared parameters even, link them with your columns, and then you can have the smart tags reference your columns and you can share data that way and make it very dynamic. a way, kind of a trick to get that system family a bit more interactive and flexible. Okay, next, I taught a class on Ride the Rails, New Ways to Build Rotation Parameters 2012. The whole idea of this class was in Revit, if anyone has ever built families in Revit and needed to rotate something, you have the classic way of doing it, which is a reference plane and a reference plane, and then an angle between them so that you can move it. But when that angle goes to 180 and 90 and 0, things tend to be a little unstable. So what I did was I taught a class on how to actually get around that. In the massing and adaptive component environment is you can just take a circle and place it down, post 2 points, run a reference line or reference plane, reference line between the 2 points. You can change the parameter at one of the points to an angle parameter. And that angle parameter can then be at 0 or 1 or 180 or 360 or 720 or whatever you want. And it's very stable. And then you can host any content you want on that reference line. And so a lot of my complicated families that have rotation in the massing or adaptive component environment, I built it this way. You could even nest them together. So like articulated construction equipment, I will actually use these, what I call rotation rigs, place them strategically so that you can actually move and rotate on there. Okay, next I taught a class called Revit Family Modeling Secrets. You saw some of those families at the beginning, like the cow and the elephant. I decided to, in that class, show how I actually built them. So one year I actually entered a Revit modeling pumpkin contest. And I made this down here, which is basically a pumpkin head, right? Scary pumpkin head. So I showed how to actually do that. Basically in Revit, you just build a series of profiles on radiating reference planes. And then you can just basically host those forms across those reference planes and you get one face. And then basically you can just copy all those faces around the circumference, and then you get a Revit pumpkin. That's the top view. There's the side view. There's some of the profiles. Not too bad, right? No, not too bad. Okay, next is 2012, oof, big year. PowerPoint's Power Plays, how to do adaptive components and repeaters. So if you need to repeat something in Revit, you don't need Dynamo. You can actually take any curve in massing and adaptive and turn them into, you can divide the curves. And then if you have adaptive components and place them on those smart points, then you can use the command called repeat, and it'll actually repeat them across those curves. So this is one ceiling component that was built just by two divided curves and one adaptive component. All right, next is exciting 2012. How to model exciting or extreme, well, it was exciting, extremely complex geometry in Revit. So in there, we actually showed how to do a spiral. So because I will do, this is a live demo, I will actually show you how to do it really quick. Okay, if you want to build a spiral in Revit, what you can do, get in massing or adaptive environment, put down a circle really quick. You can just break it like this, okay? And then all you do is you can create a form like this, okay? So here's a form, just open circle form. You can grab one of the corners and you can just pull it up like that, okay? And then you can grab this edge. You can even put a divided path on it. And then when you isolate that element, you can even hide that cylinder down below. And now you actually have a spiral. The radius will determine its size, and its height will determine its pitch. So that's how you build a spiral in Revit. Okay, because why would you do that? Because there's no spiral tool right here. That's why. Okay, just want to make sure we're clear on that. Okay, cool. Let's kick back over here. Okay, so the next one is exciting new methods to model complex geometry. I decided to bring in another example. This one basically is how do you have beams follow roof surfaces? One thing is you can use an intersection method. One more demo for today is what you can do. Let's kick on over there. Is basically you have this canopy right here, okay? Right here, and you want to place a beam along this grid. Well, if you look in elevation, this edge, you're actually not allowed to place a beam and pick the bottom of this, okay? You can only see it in 2D, but you can't pick the bottom. So, but what you can pick are actually edges. So what you can do is just create your own edge. So just take a wall and place it right on there, and then come over here and just use your join command. Join your wall to your roof. Why are we using a wall? Because basically it's a solid element. That's why. It's called, I like to think of it as like guide geometry. And look, now you have an edge there. And once you have an edge, then you can come to your beam tool, make sure you 3D snap, and then you can actually snap right to the edge. Look at that. And now you have a beam that actually follows a curve just by using what I call the intersection method. Okay, cool. So we went over that in intricate detail. 2012. And by the way, 2012, that class got top rated, got the top rated speaker award. Okay, so where are we at? 2013, another big year. I not only taught classes on Dynamo and Revit, but I also taught how to actually give an engaging presentation. And in there, I said, one of the things you need to do when you give a presentation, I suppose like today, because I'm giving a presentation, I need to follow my own advice, is you need to have a good set list, what I call set list, a good set of examples. So I have some guides there on how you can create a good set of examples to present to the audience. And it's a lot of trial and error, quite honestly. A lot of times when I'm teaching 8 examples, I've gone through probably 30 of them to find the right 8. So making a nice set list is good. I call them a set list too, because I think of kind of like, it's like songs that you'd be playing on stage. That's why. Okay, I mean, I'm not a music artist, but that's kind of the analogy I do. All right, next class was a Scale and Morph Families in Revit 2013. Okay, how can you morph families in Revit, mean change them? If you want to change one shape to another, say you want to change a straight line to a curved line in Revit, what you can do is you can actually take a straight line and a curved line, connect them up with lines that are parallel, and then host a line between them with points being hosted on those lines. Then that line can actually slide back and forth either by parameters or dragging it. That will change from lines to curves. And I do this all the time. Like, it's a lot of fun. Like, I'll morph cubes into faces, and you're like, why would this matter? But maybe you have a flat canopy and then you want to morph it into a curved canopy, right? Well, the structural engineer like it when it's flat. Architect likes it when it's nice and curved, but the owner might want something different. So you can kind of experiment with different shapes right there in Revit. Okay, another one is a class I did was how to follow site topography using hardscape in Revit. And then I gave an example of how to make a straight road actually follow topography. And this was actually a floor element. What you can do is a floor in Revit will not naturally snap to a topo, but they do naturally slap to supporting beams. So what you can do is you can actually just build beams along your road element. You can actually just basically use a split surface, put beams along there, and then your slab will snap to it, and then you've got a road that's a floor element that just follows topography. Pretty cool, huh? Okay. Oh, by the way, that class actually got the top rated award in 2013. 2014, I started getting into Dynamo. Let's go over this example, how to get and set instance parameters. Okay, so Dynamo is extremely practical. It works with Revit. It's a visual programming language. If you haven't tried it out yet, try it out. It's really a lot of fun. And then in the class, we actually showed how to take the bottom parameter of the wall and then match it to the bottom parameter of the column. That way, anytime the wall changes, the columns will follow it. Why would that matter? Well, maybe the wall changes a lot because the wall is coming from an architectural model and the columns are in a structural model. But it doesn't have to be structure. It doesn't have to be columns. It doesn't have to be walls. You can basically take any parameter in Revit and set it to any other parameter in Revit, even if they're not in the same family, even if they're across the project. So it becomes extremely, extremely powerful. Oh, and this class actually got the first place speaker award 2014. So next was Families in Motion 2015. Now we're in 2015. Do you remember that little rotation rig we had with the circles and the points? That only works in the adaptive and massing environment. What if you have a family that you need to rotate? In the classic and family environment, there's no points in there. Like if you wanted to build a window or a revolving door, but you can use a revolve actually. A revolve doesn't have to revolve 360. So you can build a revolve, some solid object, and open it up, much like you see down here. Then you get this flat face you can host things to. So you can host geometry to it, and then you can open and close that revolve as much as you want, and that will simulate rotation. And it's actually very stable. So when I build anything that has rotation in the classic family environment, I will use this revolve method. Hey, another class, Dynamo for Contractors, 2015. We talked about how to extract data out of Revit, existing Revit models, and one was this ramp basically we wanted to, for formwork calculations, calculate the bottom and side surfaces. So Dynamo, with just 4 nodes, you can extract the geometry, extract the top surface, and then get the surface area of the bottom and sides. And that can help you with your formwork calculations. Pretty easy. And why would you even do that? Because you can't replicate sides and bottom surfaces out of a schedule in Revit. So Dynamo can help you extend the functionality. Dynamo 2, another class I taught, more practical Dynamo, is how to do things other than 3D geometry. So this one, we took sheet names, sheet views, room names, and we turned them all from lowercase to uppercase. And with just 7 nodes, we took all the text in the project and moved them all to uppercase. Why would you do that? Well, if that's something that's a standard in your office, you can do it extremely quickly using Dynamo. It's a lot of fun. Oh, and this Families in Motion class got that award, 2015. Okay, next, 2016. How are we doing on time? Not bad. Okay, 2016, here we go. More Dynamo. We talked about high-tech structural engineering, some more structure focus. You can actually model framing flat, and if you have a curved surface, you don't have to model it on a curved surface. Make your life easy. Model it flat and then project it up with Dynamo nodes. So we went over that in the class. We talked about more, there was a class, cutting edge structural modeling techniques. And one is, if you want to quality control your framing, structural framing in a Revit model, turn on the analytical model, even if you never want to bring it to structural analysis, even if you're not a structural engineer. You can see framing in the Revit structural model by turning on the analytical model, and it shows center lines, and you can see if they have these inconsistencies. So it's a good quality control thing. Turn on the analytical model. Also, you can adjust the analytical model and then adjust the physical model to match. So that's what this example is. So think about that, using that, turning it on. Okay, another class, Family in Motion, was kind of like a part 2 to that first one we talked about. This one, we talked about how to simulate cable movement. So if you have like a piece of davit, or I guess any cable spooling out of maybe a crane or something, if you want to simulate cable movement, what you can do is basically host a point on that particular family, and then put a disc on there, or a circle that's filled in with an area, and host a point on that surface. Connect the 2 lines up, and then that cable motion would spool up and down based on the radius of the disc. Of course, you hide the disc. And also it can swing back and forth and up and down, all within that plane. So that's how you simulate cable movement. Okay, 2017, here we go. Coming in for a landing. Okay, 2017. I taught a class on how to go from Revit to Max Interactive, which was the old Stingray engine. And it's still around, actually. If you're a 3D Studio Max, if you own a license of it, you can get 3D Max Interactive. Okay, so basically in that class, we talked about how to take your Revit families and then convert them into movable interactive objects. So this is a piece of medical equipment, articulating medical equipment, how you can actually put it from Revit into the game engine and be able to move it around. And it's not too difficult. It just kind of lines it up basically on how the hierarchy was built within Revit, meaning it's nested components. Not too bad. A little bit of what they call flow nodes, a little bit of visual programming in there, and you can do it. What I need to mention too is that all of these classes that I'm showing are also available on Autodesk University if you wanted to go back to those original classes. So Dynamo for Structure, for example, is at Autodesk University. You just look to 2017 and you could get that entire data set and watch the original class if you wanted to. Okay, so Dynamo for Structure 2017. We started using Dynamo a bit more involved, not just for quality control, not just for documentation or building. In this particular example, we used engineering logic. So what we did was we laid down some structural slabs, and based on engineering rules of thumb, if the slab actually the span got wider based on the column spacing, which was read out of Dynamo, then the slab would thicken based on engineering logic. And so that's kind of nice because it actually gives you the ability to not have things static. Dynamo can help with that using engineering logic. And it doesn't have to be slabs. It could be like non-load bearing interior light gauge walls. And maybe the thickness needs to increase or the type needs to change to a different stud size as the wall gets taller or loads get imposed on it, sort of things like that. Okay, another class, I did a discussion group, which was a little bit out of my comfort zone, was in a structural office, who should be modeling what, basically. And this was the slide I put up at the very beginning, was like, don't touch my model, right? This is something you don't want to have happen in any engineering firm or architecture firm or AEC firm. But what the reality now is we have multiple models, right? You have the BIM, you have structural analysis, you have your energy analysis models, you have your design models, maybe in Rhinoceros, and the point is everyone needs to share them. 2017. Oh, and then 2017, that class got first place speaker award. Okay, talking more about Dynamo to the extreme, did a class on capitalizing advanced tech. Here's a project I worked on. We were doing some remodeling at the Queen Mary, which is an ocean liner museum out in Long Beach, California. We got the original drawings, and I actually built some Dynamo scripts to rationalize the hull and build the structure within Revit. So much more we could go over in 1 minute. But the point is that Dynamo is extremely powerful, interacts with Revit, and you're allowed to actually do some very complicated shapes. Okay, more Dynamo for structure. What did we do here? Okay, so this one, we actually built a curved surface in Revit, and then we used Dynamo to actually place a wall by face onto the side of the actual Revit cow. That was a lot of fun, just to show that you can actually build any type of wall shape using Dynamo. You don't have to use Dynamo. I mean, you could have done it manually, but maybe you have 300-400 walls that need wall by face, you can do that. And then of course we put doors and windows in it just to have a lot of fun. Okay, then we did a class on Dynamo for structural analysis. Dynamo is not only for Revit. Dynamo could be used to touch other databases. So the class I taught was how to take Dynamo and integrate it with structural analysis software. That structural analysis software was called ETABS and SAP. So in there, we showed how to actually extract. We took the Queen Mary SAP model and we showed how to actually extract the lengths of the frames in there. And a lot of times I get people asking, why would you use Dynamo for structural analysis? The same argument I say to use it is the same one I say, why would you use Dynamo for Revit? Revit's a rich database. Structural analysis is a rich database. You need to be able to manage, extract data, push data in, be able to quality control for all those reasons. So Dynamo is an extremely powerful thing. And then here's another example for that same class with Dynamo for structural analysis, where we actually brought the structural analysis into a game engine, into Unity, and we were able to fly around there and so on. Later on that year, or I guess later on in that week at Autodesk University, I taught a class called Zero Touch, which is basically how do you create custom nodes using C# coding in Dynamo. And in there, we actually made custom nodes. So that was a lot of fun. We even actually replicated the Revit cow in one node. That class got top rated speaker as well. 2019, how are we doing? Got a few minutes left? Okay, cool. 2019, did a class called Game Engines for Engineers. The reason I did a class called Game Engine for Engineers is because game engines, a lot of times you think of for visualization, but it has a lot of other things. It's a very rich database. It has physics, interactive, it has modeling capability. So one of the examples was to take advantage of physics is we took a project where the topography in the project looked flat, but actually was graded a certain way, and there were culverts and drains on one side of the project. So we wanted to test and see, is that topo actually modeled correctly based on the civil drawings as well as where those culverts were. And so what we did to simulate rain is we dropped tens of thousands of spheres, little sphere balls, all over the project. And then we watched them kind of roll during the class as the class went on in one direction. And sure enough, they actually did slowly drift over to the side of the culverts and then run down the culverts. So it was a lot of fun, some good quality control, but it doesn't mean you can't do quality control without having fun. Right? So that was part of the game engine physics. And if you want to try it yourself, maybe on a project you have, go ahead and do that. I could even think maybe of rooftops with like roof crickets, make your little spheres really small and see which way they drain, right? Because we don't do a lot of water simulation inside of the game engines, although we probably should in AEC. Okay, next class was connecting Dynamo with RAM structure, which is another structural analysis software. So we talked about ETABS SAP, now this is RAM. In this case, we took some grids out of Revit and placed them into RAM structure. That was a lot of fun. Remember, Dynamo is not just for Revit, could be for other things. I've even connected it with Photoshop. So Dynamo can connect with other things. Okay, and then this was the first class I taught, 2019, how to make 8 years worth of Dynamo. That's why I showed kind of the first 25 examples. Volume 1. This is when I started getting into a new software called Rhino inside Revit, where Rhino, which is Rhinoceros, a 3D modeling program, and Grasshopper now run within Revit. And this is kind of the more recent thing I've been getting into. Oh, that class actually got top speaker award as well. Thank you so much for that. Appreciate it. 2020, which was last year. Okay, coming in for a landing finally. 2020 was last year. This was the volume 2, 8 years worth of Dynamo and Revit classes, volume 2. Although I probably should have called it 9 years worth. But anyway, volume 2. This one was focused on how to, not only did we do the 25 classes, but you ever see those best of albums where you have like the best of songs, and then the last song is usually like a new one. So that's what I try to do, kind of show new content. So this is the new content I showed in 2020, which is how to get Rhinoceros information into Revit in a meaningful way. And a lot of firms will not use Revit as the main design tool. They'll use another 3D modeling program. A lot of times it's Rhino or Rhinoceros. And so you need to get that information into Revit. So one thing we did was I showed if you had these columns, which are basically solid elements in Rhinoceros, you can actually model them in Rhinoceros and put in some metadata, like maybe the size. You can embed that. Then you can use Grasshopper, which is a visual programming tool that is partnered with Rhinoceros. And you can actually get that information in a meaningful way into Revit. You could get the columns as structural columns, and the size can actually match the metadata that you put in there. Just a matter of linking them up based on Grasshopper. So this is Grasshopper and Rhinoceros inside Revit. It's a new tech. It's been out about a year. It's only been out in full release, like I think the last couple of weeks. That got last year top speaker award. Thank you so much for that. I really appreciate it. Okay, 2021, that's this year, right? So I have been focused more about this interoperability issue. And so let me just show you a little example here too, is in Rhinoceros, if you have a surface, then, excuse me, then what you can do is you can take that surface and 6 Grasshopper nodes. You can take that and rebuild it inside of Revit as native Revit topography. Now, why would you ever do that? Because if you were to take this Rhinoceros model and place it into Revit, it wouldn't, in an import or maybe an SAT import or a DWG import, it wouldn't be as meaningful as have it recreate itself as native Revit geometry. Then you can host to this topography element, you can cut sections through it, dimension to it, and it only takes 6 nodes. Now, it's not just topography, you can move other things around. But this is just one example using Rhinoceros and Grasshopper, Rhino inside Revit Tech to get into Revit. Okay, so what does the future hold? I've been studying this a lot, and I get a lot of questions like, now with Grasshopper and Rhinoceros inside Revit and Dynamo, like, is one replace the other? Like, can we use them together? What's the thing? And so this year and next year, I'm really focused on talking about how you don't need to disrupt your office's workflow if you have Dynamo. Dynamo and Grasshopper can work together. So the way it works typically is what we talked about before is Revit and Dynamo working together. Right? We showed examples of how to do like change to uppercase and build specific elements. If you have Rhinoceros elements that need to get into Revit, then what you can do is take your Rhinoceros geometry and use Grasshopper and then get it into Revit. Once it's in Revit, you can let Dynamo pick it up and do all the parameter changes and documentation and things like that. So they definitely can work together. Here's one example that I used. If Rhino had, say, a curved wall in it, you want to get that into Revit. You can use Grasshopper, the Rhino inside Revit technology, to actually build that geometry inside a Revit template family. And Grasshopper can place it inside Revit. Now, once it's in Revit, this geometry is controlled by Rhinoceros. So if that wall were to change, this family that's in Revit would immediately update and change, but it's only a surface. What you can do then is take Dynamo, it could be open at the same time. You have Grasshopper, Rhinoceros inside, Revit open, and then you open Dynamo, and then Dynamo can select that wall either manually or however you programmatically do it, and Dynamo can then place a wall by face onto that wall. Now, anytime that wall changes with rhinoceros, it'll automatically update the family using Rhino inside Revit. And then Revit, and then Dynamo will automatically change because it's controlling that host. And now you have a wall that's hosted in Revit that can now move down the assembly line and head off to production. So the bottom line is you're allowed to actually have these two work together. This is the future. This will be coming again. Thank you. If you want to see a part 4, I would love to do it. Please, when you leave, hit that recommend button. Also, please add comments and questions. There's so many of these I could demo in a question and answer session. Thank you so much, everyone. I will see you again next year. Thank you for all the support. Thank you.